Hey guys, welcome back to AlgoYogi. We are doing linked list series. Our next problem in the list is maximum twin sum of a linked list. Let's visit the problem on LeetCode. It says in a linked list of size n, where n is even and ith node basically represents a node in the list, its twin would be basically the node from the back of the list. That is like for 0th index and minus 1th index would be its twin node. So basically in the first example you can see 5's twin is 1 and 4's twins is 2. So basically they have represented it in color combo. Now what we need to return is, given the head of the linked list with even length so that every node has a twin, we need to return the maximum twin sum. So basically 5 and 1 makes a 6, 4 and 2 makes a 6 too. So basically it's both are equal and answer is 6. So that's okay. But then now we have 4 for in our example 2, we have 4 and 3, which makes 7, 2 and 2, which makes 4. So answer is 7. That's max. All right. And then there's third example, cute example here. So that's just 2 nodes, we're just combining them, and it's like 1,000,001, not million, 100,000. Yeah, 100,000. All right, so let's understand how we're going to approach this problem. This would be similar to the problem we just solved. That was like reordering of the list. I think that was a preparation to solve this list, which we did using basically slow fast pointer, taking the second half of the list, reversing it, and then playing around with the pointers. Here is just, we just want to find out each node's twin, combine them, and update our result. So if you see the list over here, first way, brute force approach would be take an array and store all the nodes into the array, then have 2 pointers I and j, and then basically move them together. So this, initially they'll be pointing to these two pair which are twin, and then we can just have result would be, initially it would be 6, and next time we move our pointer basically closer to each other. So j will be moving backward and I will be moving forward. So this becomes I and this becomes j now. Then we combine them. This is also 6. So it will, answer would be max of 6 or 6. That makes it 6. Now this answer is really straightforward to implement, which is just taking an array, iterating the list, placing all the nodes at the index, taking 2 pointers, moving them closer to each other, and at the same time just combining the sum of their basically the values of each twin, and then updating our result max. Now this will take time big of n, and space complexity is also big of n because of we are using an extra space for the array. Can we do better? Definitely. How? Using the pointers. So that we take this list, we're gonna take this list and let me just clean it up for you guys. So we take this list, and what we do is divide it into 2. So that will be, let me not do it just an array, but we're gonna divide it into 2 like this, and that we're gonna use slow fast pointers so that we reach the middle of the list. And then we take our point, then we reverse one of the list. We can reverse either this or this so that our twins basically occurs in the same order. So 5's twin is right now in the end of the second list. So if we reverse, let's say we can reverse either this list or we can reverse this list. We can reverse any of those. And if we do, let's say we choose to reverse the first list, then it will become 4 and 5. Although now my head would be basically 4 here, and this will remain same. But now see how these two lists have all their twins together, 4 pointing to basically 5. Now 4's twins is basically 2, that is over here, and 1's twin is 5, which is over here. Now we can just iterate these two lists and update our answer. that's exactly how we're going to do it. And we can make a decision if we want to reverse the first half or second half. I think reversing the first half would be better, because we can do it along with when we are trying to find the first and second half of the list at the same time, because we will be doing it using slow and fast pointer. So when slow pointer is basically traversing all the nodes in the first half until the fast reaches the end of the list, and that's where slow stops, and until it's traversing till the middle of the list, it's traversing through all the nodes. So how about at the same time we just reverse them right there? All right, let's do that. And I think the brute force approach would be easy to implement. It's very straightforward. So I'm not going to write that solution, but I'm going to write the most efficient one. What is it? Take slow, take fast, initially both pointing to head. All right, and then we also have like previous. That's our go-to node when we are reversing a list. So initially pointing to none, and while our fast and fast.next, since it moves 2 pointers, so fast can point basically fast equals to fast dot next. Now I know we need to do slow equals to slow dot next, but before we do this, we gotta play around so that we at the end of the day slow is our previous is pointing to the reversed list. The first half of the list is reversed, and our previous points to the head, the reversed head. And slow is basically gonna slow is gonna point to the next half of the node, like next half of the list, but the first node in the list. So what do we do is, I'm gonna, once I write the code, I'm gonna explain it on the iPad as well, so that it looks pretty good to us in terms of understanding what we are actually doing. So let me do it later. I don't know why I started erasing things over here, but let me come back and write the code. All right, so what we're gonna do, have like a next pointer and store it from let's call it slow.next, and then slow will be pointing to next. We're doing the same thing. You see I'm doing the same thing. It's just I'm using this temporary variable to store the slow.next, because I'm gonna play around with this here. So what I'll do, slow.next will be prev, and my prev would be my slow. Right, my prev would be my slow, and then slow goes up to the next, and then it keeps going on. So now once I come out of here, I have slow pointing to the reversed first half of the list, and prev pointing to the reversed first half of the list, and then slow is pointing to the next, the next half of the list head. So I'm gonna have result calling it 0, and then I am going to say, let's say while I think any of them right now, they might be, since they're gonna have both equal number of nodes, because we are dealing with even number of nodes right here. So we can just say while slow and result would be maximum of result, and slow dot value plus prev dot value, and then we're gonna increment slow prev slow dot next and prev dot next. All right, I think this is it, and finally we return the result. Let me zoom out and see if this works. Let's go over it again, and let me also show you guys on the iPad as promised, that I really want to show it because that's how we understand better. So we took this list, and we convert it to basically 5, 4, 2, and 1. Then we have our pointer, let's call it fast. Then we have slow. Then fast moves like twice, so fast will be over here now, and then in the first iteration, and then slow would be basically slow comes over here. This is slow, but at the same time we are reversing it as well. So remember, you guys know already like how we reverse using temporary pointers and everything, so you would know. And slow is pointing where. Next time fast will be out of the thing and slow will be basically pointing to 2. So slow is pointing over here, and then this reference is gone, this reference is gone, and our previous is pointing over here. So this is where my previous pointing. Now these two lists, 4 pointing to 5, I'm gonna write them again nicely, and 2 and 1, this is my basically slow. This is my slow, and this is my prev. This is the reversed first half of the list, and now I'm traversing them simultaneously, just adding these pairs up and then updating the results to the max. Then let's run our code, because it seems it's gonna run, and it did run. Let's see, let's go. All right, let's write down, no, we're gonna submit it. There might be some edge cases, and hopefully they're not. 52%, okay. Anyway, efficient. Time complexity is big of n, and space complexity big of 1, because we brought it down from our brute force approach, storing these values into the array, and then playing around with the pointers over there. And let's go back to AlgoYogi, mark this problem solved. See you guys in the next problem. Until that, bye bye.